Hi, this is Tag again, and unfortunately, I completely forgot to record this time while I was still benching. But I did run the P5K, the vanilla version, on phase change for the North Bridge and Cascade phase change for the CPU. So I was running about minus 55 on the North Bridge and minus 90 on the CPU. As you can see, my usual Molex volt mods here. The left one is, I think, on the eSATA ports, or eSATA and Firewire, and the right one is on the audio port, because those are useless for overclocking. Now this is a PCI GeForce FX 5200. I use PCI because on some boards it definitely helps with FSB. I have yet to properly test it on P35, but it's definitely not gonna be worse than a PCIe GPU. Postcode card, single stick of Corsair XMS2. Those are D9 GMH based. I managed to get over 740 valid out of this stick, so it should be fine for maximum FSB runs. My highly professional Northbridge single stage mount. That's just 6 copper slugs from the Intel stock coolers, all taped together. Weighs about a kilo. Bit short of a kilo, I think, 800 grams or something like that. Anyways, usual multimeter setup. Unfortunately, nothing displayed anymore, and I can't just turn it on to show you because there is like a puddle of water around the North Bridge and probably around the CPU and the insulation as well. So I think I will just switch to the bench and do a bit of a recap of the two P5K sessions, both this one and the workstation board.
Okay, so I decided against the bench and for the computer this time. Just going to go over my two little P5K scores. Now, this is actually, I did remember to take a picture, but I didn't remember to make a video while I was running it. So, this is the P5K vanilla. And as you can see, the actually middle is Northbridge voltage, and the left one is VPLL. Now, what I found out with this board is that Northbridge voltage, just like with the other P5K, that workstation board, it doesn't really scale with a lot of it. Now, I tried up to 1.85, but the sweet spot was somewhere between 1.725 and 1.775. So 1.75. With the other board, it actually was a bit lower, I think, even. This here is just VPLL. Now, it also was kind of strange. It's almost like these P5K boards don't like as high voltages as X48 does. I ran 2 volts VPLL, which is not all that much for a 65 nanometer chip. I'm on a E6400 here, so low-end Core 2 Duo. Now the other voltages from memory were roughly 2.45 volts on the memory, just to be safe basically. V-core was pretty low actually. This board did worse at 1.7 volts V-core than it did at like about 1.65, so that was about the sweet spot for V-core for me. Which is also really odd because usually on Cascade you can just give the CPUs like 1.8 and it's perfectly fine, even with like, especially for maxing out BCLK. So rather weird behavior now. The rest of the voltages I was running about 1.4 volts VTT or termination, and I'm not entirely sure. Uh, I don't think there's any other major voltage I forgot here, so that's it for voltages. Now, a quick note on the behavior of this board, and I was positively surprised, I should say, because for me it felt like the error recovery and like the, how should I say, reliability uh, of the board, like doing the same thing at the same settings every time is higher with the like stock P5K than with the work session, which is honestly surprising. This one I ran like into no post a couple times, and error recovery worked flawlessly. On the P5K WS, it was a bit different story at certain voltages. It started behaving weird and didn't recover properly. Now, also with this one, I did some uh, GTL tuning, but it didn't seem to help a lot. Just like with the P5K WS, so I'm not sure what's going on there. Either I'm not really doing it right, or they're just really forgiving boards in terms of like ease of use, which is might also be the case. So far, pretty heavy with P35 to be honest. It is like way easier than P45, definitely, to get to clock properly. I would say this is one of the easiest chipsets so far that I have been messing with. Other one maybe X48 ASUS. Anyways, let's move on to the uh, WS board. Now there is even a bit lower VTT here. That is the VTT, and the middle one is our Northbridge voltage. So I think this is 1.77 or 1.72, 1.71. I don't know. Uh, this definitely wasn't the sweet spot because I can remember it was below 1.75 on this board. So uh, the screenshot is probably from a different try. Anyways, I was running a different CPU here, and that might also be the reason why I only managed 672 because it felt like kind of CPU limited. But to be honest, that would be sort of weird because the CPU here does 600 FSB on air, and usually you get about 80 megahertz from air to cascade. So I would expect at least 680. This is also a 600 plus air chip, but uh, here, as you can see here, it does 681. This chip should definitely do more as well. And this also felt way more board limited. Can't really explain how the like feeling works, but it's something you pick up if you like deal with a lot of CPUs, I guess. Again, it's if you can't really describe a feeling when overclocking. That's kind of unfortunate. Also, PCI GPU here, of course. Uh, Luckily, it has two slots because here I couldn't even run PCIe because my phase change here blocks the PCIe slot. Now, I really want to give this one another go and also the other one, but I think this time I will do it with something I actually bought these boards for, which would be Xeons. Now, as some of you might know, Socket 771 Xeons, at least the 5000 series, does not work on X series chipsets. So you're basically limited to P45 or P35. Uh, let's pull up an example. 5130. I'm just using this one because I have a decent chip here. Here we are. And this is also super low multi. So as you can see, X6 maximum multi. That's also the minimum multi coincidentally on 775. So this is the pure FSB chip if there ever is one. Now this is on a ASUS P5Q-E, I think. Yes. Also North bridge on single stage phase change, cascade on the CPU. Now this CPU definitely has to do more because this is also one of those 600 air chips. That's actually my third one. I only have three chips that do 600 air. One is the 6400, one is the 6300, and the third one is this Xeon here. And basically the whole reason I got into P35 was being able to run these 5 series Xeons. Actually pull up the rest of them. These 5 series Xeons at really high FSBs. So let's see if we have something here. There we are. So as you can see, pinning nodes on this 5 series Xeons, I have a bunch of them here. These are quad cores. That doesn't really matter for this, but I think even the quad cores will perform better on at least the 65 nanometer quad core. So the 53 series will perform better on P35 than they would on P45. Now, as you can see here, this is 590. Now, when I say 600, I mean 600 with tweaked VPLL. Now, these chips scale with VPLL on basically any cooling usually. Strangely, some of them didn't like really high PLL for me on P35 on Cascade lately, but this chip does just about 600 with I think 1.8 or 1.9 volts PLL on air. So all my binning data is with 1.5, so stock. So can you see a couple chips here? Most of them don't even do 550. That's basically what you gotta expect from Conroe, so 65 nanometer Core 2 Duo in general. That's there you can see 5120 different Xeon. Best chip does 575. 5100 I actually don't even have a good one. So but I basically want to run all these, and there I have one, and the single sample does 580. Sometimes you just get lucky, I guess. Uh, Anyways, basically the whole target for me getting into P35 was just to play around with some Xeons. And I think that's the next thing I'm going to do on the P5K. I'm yet to decide if I'm going to use the workstation or the like vanilla version, or if I'm maybe picking up a P5K-E. There is one listed, but it's 15 euros, and that's not really super cheap. And yeah, I actually paid 15 euros when I include shipping for the P5K vanilla, so also kind of overpaid, I would say, for a P5K at least. But I really wanted one because I wanted to see how good like the baseline board was, and it was surprisingly good. Uh, so I would say definitely a recommendation from me for the P5K uh, stock board over maybe even over something like a WS, but like in my opinion, the whole P5K series is a really decent one. Surprisingly so, because now, as you might have heard me talk about layer counts with the uh, P5E3 Pro, this board here, the stock version, is also a 4 layer, and the WS is a 6 layer. But there is not nearly as much difference as I would expect. So basically my theory why it matters more on X48 currently is that X48 has more PCIe lanes, which makes routing them on the board more complicated. Also, maybe it's just a, well, lucky coincidence, I would say, that ASUS managed to build a 4-layer board that actually clocks well. Because usually all the good boards are 6 or 8 layer. But there is exceptions like this P5K, which is really nice. Anyways, this was, I think, 10 minutes of solid rambling about P35 and like voltages, scores, stuff like that. I hope this wasn't too long, and I hope you at least watched to this point. Bye.